Thanks for staying so long here. And welcome for my little talk about the quest for the ultimate parser library. So, sorry. I first wanted to know a bit about you. And so I reload this page, and so you didn't read the rest. Who knows what a parser is really? 1, 2, 3, yeah, okay, good. And have any of you implemented one yourself once?
I had implemented a Lexer.
Mm-hmm. Okay, that's the
Lex and Yak.
Mm-hmm. Yeah, okay. That's the first step already. Yeah, good. And good. So that's fine. So I know a bit, and I don't talk too much or not enough about something, and great. So now about me. So I'm a long-time software engineer and did Java for many years, and now for quite some time Go. Wow. And I'm also one of the organizers of the Berlin Go meetup. And yeah, now let's see what parsers are about. So in a very short thing, they help to read and kind of understand any kind of structured input. Well, that doesn't say much, right? So what is really structured input? It's, for example, code for a programming language, like JavaScript or Java or Go or whatever else. The first step is always you need a parser to take everything apart, and then you do something interesting with that. And configuration files have to be parsed too, but they have usually specialized parsers that are highly optimized for that. And really domain-specific languages. This is the big thing where you actually use, yeah, welcome. Come in. So please grab a seat. Yeah. Come on. So most parsers are really used to build a domain-specific language, like when you have a company that's all about something, like how to work with some product, and you have some keywords and so on, you can build a DSL that reflects those things, and then you can have something that can be used by people that are not IT engineers but know a lot about the product and what the company is doing, and they can do things then with this specialized language. And so this is what most of the parsers built by normal people are about. And I needed a parser for own special DSL, and so yeah, that's how it all started. So a small example here, it's a very simple one. So we have some data structure that we want to fill, and we want to pass some alphabetic characters, and afterwards some digits, and then these alphabetic characters and digits we fill into this data structure by the first part, conf being getting the alphabetic characters, and the year getting the digits, and we don't have any error here, and then we run this parser and print out the result. So let's see what happens. So, well, DevFest 2025, right? So it has been recognizing the string here correctly. Right, this is the string that was recognized, and it starts with alphabetic characters, and after that is the number. So it's a very trivial example, but I can live code it here. So if I'm saying 2035 and I rerun it, I get a different result, and so it's no fake or so what I'm doing here. And fine. So just very, very simple thing. So, but what was I looking for as my ultimate parser? So I wanted something maintainable because I didn't want to spend my life working on parsers, but I was only the base, the very start of a much bigger project. So I wanted to spend only a little fraction of my time in the future on this parser thing, so it should be maintainable like all the rest, like a normal library, like any other dependency. And yeah, error reporting is important, of course, right? When you have a programming error, you want to see which line and column it is. Often your IDE is already putting you in the right position with that information. And having a code snippet is great when you don't use an IDE. And you can already, when you see the error, often, if it's something trivial, like a missing comma or so, find the solution while you look at it and switch back to the editor. So I really like that. And of course, I would like to have multiple errors. Right? This is the thing you will notice later, that it's a bit special. And of course, we want to fix all errors at once. Right? It's not so important for machine-generated input. Right? When the machine does a mistake, you stop and say, sorry, wrong, try again. But for human-generated input, we do mistakes all the time, so we need all the errors, or at least a bunch of them at once. The Go compiler, for example, reports the first 10 errors and then says, sorry, that's too much. And often the later errors are just things that will be fixed when you fix one of the earlier ones. So this is fine. But one is simply not enough. And nowadays we want Unicode support, of course, right? I mean, who doesn't want to program with smileys or something? And at least you want to be able to output such strings or something. So it is important to be able to work with it properly. And type safety is great, right? In Go we have nowadays generics too, like most other folks, and yeah, Java, for example, also. And so I would love to have that I really know I get this thing out of it, and the compiler complains if I plug things together in the wrong way or so. And having idiomatic Go code would be really great too, of course, right? I mean, it goes along with this maintainability thing that I started with, but yeah, it's a bit special. And in Go, we like to have really idiomatic Go code that's like code written by the Go team at Google or so, like the Go compiler and the standard library look like. And so we've taken a lot of patterns from there and like to mimic it everywhere else. And it helps getting readable and maintainable code a lot. So let's see. And finally, supporting binary input would be nice too. I don't need this for my project really, but if possible, this would be really nice. And ideally in the error messages, having a byte position instead of a line number and a hex dump is small around this error. This would be really helpful. Then you often don't have to do something funny, but often enough see the mistake immediately. So, yeah, and last but not least, maybe good performance. Yeah, at least for the feature set, right? Of course, everything has its costs, but having somewhat good performance is really desirable. So let's see how we can do about it. So let's start the quest. So I looked at some parser libraries and parser generators from the Go community, and most have really some cool way to go about things. There's one where you can match a string. If you look for a static string, like a keyword, for example, you can match it by just giving this string. And it's turned into a string parser, string matching parser by some background magic. That really looks cool, and reading this code is really nice. But, well, it has its downsides also. And there are other things where you can have a parser where you just have a data structure that you want to fill, and then you have add some text to these data structures, and then these tags help building the parser, and you don't need anything else, just data structures with tags, and then everything else is done by magic machinery in the background. Really cool stuff, but yeah, unfortunately, they are all hobby projects, like demos, and it's impossible to find something that can meet the more difficult criteria. So, especially multiple errors, there's not a single one that would do that. So I attempted to write my own, and yeah, well, maintainability of a normal library. As I investigated quite a lot of parser libraries, one stood out. It was Gopher. So many thanks to that one, because it has this nice maintainability, and it has type safety too, and using generics and so on. This is really fine. And it's also written with Idiomatic Go code, and this is really, I love all that about it, and has quite some good looking benchmarks, and I thought, yeah, this is a solid base to work on. And well, Unicode support, well, it says it has some, and you can pass strings, and it can also pass bytes, but internally there is a bug where it is really only parsing bytes, and the characters are not kept together, and so on. So it doesn't really work for characters that span multiple bytes, and like umlauts, for example, in Germany, and so on, and smileys or whatever else. And so, but I could fix that in a day or a bit less. So I was quite happy with that, and error reporting, doing much nicer with line number and column position and a code snippet. I had an old parser project where I could mostly copy it and adapt it in a weekend, and then it looked really great, and I was quite happy with that. So, and even support for binary input, right? I could include byte position, hex dump for errors, all of that with some help with a standard library and so on. It was quite easy, a bit less than one more weekend, and that was done. So what was left? I was almost there, and it's a few weeks, and great. So reporting multiple errors. This is the one thing that seems to be harder than everything. But I still have got this old Parser project somewhere, and I remember it reporting somehow multiple errors. It was like almost 10 years old, and so I don't have work memory about it, but I should be able to work it out. And well, reality, it turned out that the project does return multiple errors, but they are all about the same error in the input. So I get just more context, right? I get more messages around it. But it's not that I get information about multiple errors in the input. So, yeah, from different levels and so on. And I thought, can't be that hard to change it, right? Come on. And so, reporting multiple errors. The next level, it turned out that it's not just a matter of adding a loop somewhere in the right place, because I do it once and then I have to just do this multiple times to get multiple errors. Unfortunately, it's not that easy. I have to try harder somehow in different ways and how to restart something. And then, I tried several, intuitive, in hindsight, rather naive solutions, and I've all failed really miserably, right? I really got nowhere. And yeah, so I had to look beyond the Go universe. I was everything in Go I tried and whatever, and looking at the Go parser itself wouldn't help much because that is a highly specialized thing, not something general. And so yeah, taking a deep breath, after a while I took a look at Antler from the Java community. And well, it's a well-known parser generator, and it's a quite professional project and can even generate parsers for many programming languages. So you need a JRE to run the generator, but the code that you really use later in your own project can be in your own programming language. They support quite a list of languages, so that's really, really great. And Go is one of them, so I was really happy about it, and has a really big and vibrant community. I think this is the thing you have to measure yourself with in the end. This is the professional solution that you can find in that field nowadays. Except if you are maybe using C, and then Lex and Yak is still the thing. But apart from that, I think this is really the way to go. And well, this is what the DSL looks like. So I am using JSON as an example. It's not a complete one, but an extract. And so you just want to pass a JSON value, and then you should reach EOF. And what is a value down here? It can be either a string, a number, which I don't show. It can be an object, which I show, or an array. It can be a literal true or false or null value, right? We only know JSON a bit, right? Somebody doesn't know JSON at all? Okay, good. So, and objects are just these curly braces, and potentially you have like pairs of key value things inside, right? The key must be a string, and then you have the colon as a separator and the value. And this all looks quite readable and nice. An array is similar, just in square brackets, and then you have these values, possibly multiple following, and yeah. So that's all quite nice. And So this DSL is really readable, and there are tools for debugging it and so on. And so this is really one of the strong parts of ANTLR. And yeah, so what I would like to have the code that is generated by it would look like. So this is from my own library in the end. So I would love to have this thing where I pass a value to say, oh, let's take either an object, an array, a string, or a float, or a true value or a false value when you encounter the string true or false, or when you encounter null, you want this null value as a special JSON value converted. So this is this type safety thing. I wanted this special JSON value type filled. And yeah, this is what I would have loved to have, something like that. So you can see it's a bit similar to this, right? This, and the next one, the array, is this. So I have these square brackets here, and they are separated by a comma and something like that. And then you have elements and blah, 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 and you match those and can return them. This would be really readable and lovely, and then I would have said, oh, best tool ever. So let's take a look what the thing really looks like. So it generates multiple files. So the generated Go files are this JSON, because that's the name of the grammar, base listener Go, JSON lexer.go, JSON listener.go, and a JSON parser.go. So I get 4 files instead of 1. And yeah, to be honest, these 2 listeners aren't really necessary. You can leave them out, and then it would be only 2 files, the lexer and the parser. But you always get these 2. But okay, maybe with 2 I can live. But it's maybe not what I expected, but yeah, let's see what the code looks like. Right? And so this is what the code really looks like. This is the JSON parser initiation. And yeah, here you can find something. These are the constant strings somehow. And I don't know what here. Rule names, okay. Some things I recognize from the DSL. But here I'm completely lost. I don't want to debug that any time, and yeah, it's getting not much better. When I scroll down, there's the rest. It doesn't tell you much if you didn't study this kind of parser building and how they work internally and so on. You basically don't have a chance to fix a bug there. So then it was the question, what else can I do? So get to the next slide, please. Sorry. So now, okay, so finally, how do I use this generated code? So input, I first have to give it the input string as an input stream, and then I can build up this lexer from there. And then I need a common token stream from there, and then I can finally build the JSON parser, but I still have to add an error listener myself, and you really should implement your own error listener here, because the general one is often not what you want to do and want to have. Then you can finally call the parser. And so, well, it's not really what I expected as a user experience. And what the result looks like, what you get back from the parser, is this interface. And well, I don't find any normal value from the DSL in there or something. You can get the values out of it, to be fair, but you have to go deeper, and then it's a quite a bit abstract code. It's doing its own abstract syntax tree, and you have to go down that special data structure, and it's lots of interfaces with only one implementation and so on. And in Go, we have this saying for idiomatic code: you expect and accept interfaces, but you return values. And but they return the interface, and I couldn't find a place where they accept this interface. So this seemed to be exactly the opposite way around somehow. And I thought, oh, this is not idiomatic code at all. And yeah. So my conclusion is a bit, a real programmer can write Java in about any programming language, right? And I got to find out how and other parsers are really doing this, recovering from one error and being able to report multiple. Unfortunately, ANTLR itself is working in a very different way from parser combinators that I would like to build. And so I had to read a paper instead, and I went to the academic folks, and this part here you see, it's kind of the DSL a bit that ANTLR is also using. So this is the nice part, and they do some explanations about it. And I thought, oh yeah, I will understand, this is nice. And then they talk here about error recovery and so on. And the real explanation is all this. And here I got lost. A few of these symbols, like this one, they explain in the text, but most of it is a given thing in the field, right? If you are on the know, then you can happily read this for Sunday breakfast, but I had to study it for quite a while, and then for a few days I really understood how this works, and in the end it kind of either deletes input or it adds input. So, and then tries again. I thought this should be possible somehow to mimic in my own thing also. So next attempt at error recovery. So I have the right pointer and I'm in the right direction now. So, but parser combinators are a bit different than these peg parsers that they were talking about in the paper. They are working with the call stack because you just have normal functions inside functions and so on. So this is so that the call stack is really important there. And so individual parsers can't be easily called without this context, right? Because it could parse something, but what do you do afterwards? Right? Then you are lost. And so I wanted to go with the flow and like with the call stack, like use it as a tool and not try to work against it. And well, that turns out I need multiple modes for that. So the standard parsing is a happy mode, right? When everything is good and nice, I can parse forward and generate some nice output. But if I have an error, I enter this error mode, and then I have to go back and backtrack. It might be that I'm in an alternative that is wrong, and the next alternative is the happy path. So I go back all the way until I either see there is no alternative, or I hit a so-called, I call it now safe spot, where I see when I hit this, I've passed it, I shouldn't go back beyond that. Because I, for example, passed a keyword, and if I passed a keyword already, I know there's a for loop, I can't go back and try parsing an if loop instead or something, right? If I have the for keyword, it doesn't make sense to try any of the other keywords instead. So I have that, and that's where it stops, and then I have to handle the error. Then I go forward again until this error position where the erroring little subparser is, and then I handle it by either removing some input or adding something. In reality, I just, instead of deleting something, I moved the pointer in the input a bit forward. And instead of inserting input, I just ignored the failure from the one parser, and then I have inserted correct input, right? And so this was relatively easy. But I have to, of course, then go forward again and try if this really works. And if the next parser still fails, well, that wasn't successful. Then I have to rewind and go back to the error position and try to remove a bit more or something. And well, if it all fails, I have a last resort, that is the escape thing, where I try to find the next safe spot on the way, and then I, like the next keyword or something important or that should be passed, and then I go on with that, and I find and I ignore everything else in the input until I find this safe spot thing. Then I know, oh, I am really in a position again where I can restart the parsing and so on. This is a last resort, and it's not so nice to happen, but yeah, let's see. And well, it turned out these are 1, 2, 3, 4, 5 different modes, and well, all of them have to be implemented for all those branch parsers. So those like looking for different alternatives or applying something multiple times and so on. So right, there are quite a lot of parsers. Oh, sorry. So, and I have to do like 5 implementations for each of those, and it got a real mess. The complexity basically exploded. So back to the drawing board, right? What is it really that makes error recovery possible? And so this is kind of the solution. So it must be possible to call a parser directly somehow, and these branch parsers must be able to run after some child parsers, so they don't do everything, but then start somewhere in the middle. And so all parsers need an ID, so I can tell start after that ID. And yeah, then I use the parser with the least waste for recovery, so I don't have to jump far, but can take the next keyword or next valid input and go with that. And all parsers are kept in a slice of base parsers, so I have them in my orchestrator, and then I can access them all. And of course, I need to remember what was the parent parser, so I can go and call the parent and then the parent of the parent and so on, because I don't have the call stack anymore. So yeah, parent parsers can be dynamic, so it's not so easy. You can be used in multiple places, and expressions with parentheses, they turn the hierarchy upside down a bit, and so it's all not so easy. I have one last tough decision. We don't have time for that, so I go beyond that. So I have one more complex example here. So this is a mathematical expression with so prefix operator, this minus, like -5 or something. Then you have the next level with infix operations like times and division, and here you have plus and minus on the next level, and finally I want to add parentheses too. And yeah, I can run that, and I can have an expression like a name equals and then this thing, and yeah, so I get this result. It's running nicely. I would have loved to have a bit more time, then you could have tried to insert some errors, and you could see the error reporting. How much? 3 minutes or so?
3 or 2.5.
Yeah, okay. Maybe I do one error at least. All right, so you still get the output, but you get also an error that the letter is expected, and it found this dollar at this position, and this is the code snippet, and so on. So this is quite nice, right? And you can get multiple of those, I promise. But let's go on. So then I, of course, wanted to have good enough performance also, and I had a number parser. This was easy to implement and something you got everywhere. And I compared it with the base I used, Gopher, which has it a bit too complicated way to implement it, and so it got quite slow. I have quite an optimized way, so that's the nice thing about parser combinators. You can have optimized subparsers, and ARR is quite good. So, but let's take a look. 2 nights ago, I started to do more complex examples like JSON, and suddenly, oh, my parser didn't look so good anymore. Maybe I have some overhead somewhere, and more complex example might be better, but no, sorry. Well, sorry, my conclusion is this quest still goes on, right? So, and ARR is a good solution. Would have saved me lots of time, and even enough for fixing all the ARR problems that I might encounter in my own life. And well, but I didn't do it for myself. I did it for humanity, right? So it's of course worth it. And yeah, thank you very much.